All right, so we're talking about topic of proof of work and proof of stake tonight. So it's an important topic because Ethereum has just merged to be secured by proof of stake, and I think it's about a 50-50 split now between the assets in the world, in the digital world, that are secured by proof of work and the ones that are secured by proof of stake. Ethereum actually secures a lot of assets, so with that move to proof of stake, a lot of the cryptocurrency in the world did move to being secured by proof of stake. So tonight we're going to talk through the differences between proof of work, proof of stake, the trade-offs, and my friend Anthony, Sigma Prism from the Ergo community, will be joining us shortly after I go through a small talk about proof of work. Unfortunately, we will not have an intro to proof of stake tonight. Big Pey got caught up in a storm, so unfortunately, we're just going to have an intro to proof of work, then we'll have a discussion about proof of work versus proof of stake, and I hope everyone can learn something. So proof of work, my name is Matt, and I am representing the Nervos Foundation today. And before we get started, I want to go through a couple of concepts just so everyone has kind of a common base to start with. So the first concept is the concept of a node. So nodes are computers that store the entirety of a blockchain, say the Bitcoin blockchain, and as there are new blocks added to the chain, they sync those blocks, they share those blocks with other nodes. The next concept is the concept of a miner, or an ASIC, a mining machine. This is a machine specifically designed to mine cryptocurrency. And now let's talk about proof of work. So many people have heard of proof of work in reference to Bitcoin, or in reference to the environment, or how proof of work is setting the environment on fire and we have to do something about it. People may have seen images like this, many large warehouses full of machines, and they've been told that miners are competing to solve math problems or computational puzzles. But what's really happening here? So there are these ASIC mining machines, and there are lots of them, literally millions of these machines in the world. And they are all bundling transactions with a random number and putting this through a math equation to find a winning result. That gets fast. To find a winning result. And all of these machines at the same time are repeating the same thing with different random numbers, trying to find this result. And once one of them finds it, the Bitcoin nodes in the network all propagate that result to each other, and they all check it. So every one of these nodes is checking for themselves that the solution to this problem is accurate. So you see that each node validates a block and stores it. And this is important because of this concept of trust, or with proof of work, the lack of trust. It's just math. That's all anyone has to trust in, is that math functions as we would expect it to. 2 + 2 = 4. And we see this in syncing blocks of the chain. So Bitcoin starts with the Genesis block, which includes the text, "The Chancellor is on the brink of bailing out banks." And if we're here in 2022, we need to find all of the data that links back to that first block. And nodes follow the longest chain. And this is simple and easy to understand as far as the consensus protocol goes. And sitting here in 2022, we would just find the longest chain that exists today that starts with that same Genesis block. Now, if we were in, say, 2010, we would do the same thing. We would just look for that block. Now, if someone just disappeared, just went offline between 2010 and 2022, they would just repeat this process, and we call this a Sleeping Beauty process, that a node doesn't need to trust anything, it just needs to find the longest chain. And there's no trust, it's just math. A similar thing happens if we want to sync a mobile wallet. So instead of checking the entire blocks themselves, we can just check the math problem, and we can just sync that. And this is very efficient. So there's no one to trust, just trusting math again. But instead of having to download an entire blockchain, you can just download a small amount of data with your mobile phone. And this exists today. This is not something that's a roadmap item or anything like that. This has existed since Bitcoin started. And it is an absence of trust, just math. Now, when we talk about mining, we know already that all the nodes follow the longest chain. And once a node sees that someone has solved this problem, they add that block to their chain. So there's no concept of identity. There's no authorities to trust or anything like that. It's just math that we're talking. And it's permissionless. Anyone can mine. It's also borderless. So there's no notion of any entity being tied to the United States or another country. It's just literally a math problem that someone sees, that someone has solved a problem, and then the chain progresses. And this creates a network that's always in flux. So there was a time when China controlled 50% of the Bitcoin hash rate, and then China banned Bitcoin mining, and now the US leads the world in Bitcoin mining. So it's always in flux, it's always changing. If you have energy, say if you have a hydro dam, or you have wind turbines, or solar panels, or nuclear, or even a volcano in the case of El Salvador, someone will just plug miners into this. If you have that excess electricity, it's there for someone to mine Bitcoin. And this is leading to innovation in terms of the usage of energy. So this is an example of a gas flare where someone is drilling for oil, and a byproduct of that is natural gas coming out of the ground. And the best thing that they can do is just burn it, because it makes no sense to do anything else. But with Bitcoin mining, they actually can plug in a generator and capture that methane gas and plug miners in it and convert it to Bitcoin. And now we have less emissions that are going into the atmosphere because there's an economic incentive to actually capture it and to use that and turn it into energy. So mining doesn't care where energy comes from. It doesn't require any infrastructure or transportation. You don't need to build a power grid, to take advantage of excess energy. And it can balance electrical loads on an energy grid. So energy grids are built to capacity. You can't turn down the amount of electricity that's being generated. So if you think about it like a wind turbine, if that thing's spinning, the energy has to go somewhere. So Bitcoin miners can be plugged into an energy grid and use that excess energy. And they can also be throttled down at any time. So if that excess energy is not there, then you just turn off the miners. So that allows them to buy low price or negative price energy. So this is already happening in Texas today. So Bitcoin monetizes this concept of stranded energy, just energy that is there, say a waterfall, that there's obviously energy there, but there's nothing to do with it. But you can plug miners into it and you convert it to Bitcoin. So there's economics of all this. So mining uses large amounts of electricity. So it's comparable to a medium-sized country. And it's a highly competitive industry. Because this idea that anyone can mine, anyone can plug in miners with any sort of electricity creates a real free market. So yeah, anyone with electricity, plug in a miner. And mining hardware costs are high. We were talking about millions, hundreds of millions of dollars maybe. So miners are committed to securing the network that they're plugged into. And all of this cost has an impact. So if we look at the Bitcoin price, mining profit margins are thin. So, and technological advances require reinvestment. So most of these coins that are being mined are getting sold back to the market just to cover costs. And this creates a downward pressure on the coin prices and turnover in the mining industry. And it means that a leading spot is never guaranteed. And these miners are service providers to the system. They don't own the blockchain that they're securing. So now I'll move into some caveats about proof of work. So it's not for every chain. There's specialized machines that have to be made. You have to build a community of miners, and that's just not for every blockchain. And proof of work can also be attacked. We've all heard about the concept of 51% attack, so it's a very detailed subject of how proof of work can be attacked. And mining pools are a source of centralization. So you'll see charts like this where they say if you controlled 3 of these pools, you could take over Bitcoin, which is true to some extent. It's a problem, but there's always solutions to every problem. And given the energy consumption of proof of work, we need to continue to make it more useful and more sustainable because proof of work isn't going anywhere. And as I showed in that methane example, it can provide things that are useful. And we're supposed to have a talk about proof of stake right now, but I invite Anthony to help me to do the best we can to explain proof of stake and just communicate to everybody, and let's do it. Big Pey got caught in a storm, unfortunately, so we're not going to have that presentation. Yeah, we have a second microphone around here.
Yeah, I'll go through a few bullet points as well, and then we'll open up the discussion so it's not super forward. That's it, maybe.
No.
An hour of people just listening to bullet points.
Okay, you got this. Okay.
Am I in there? Yeah. Okay. So, yeah, thank you again for everybody for coming out. Whether you just trickled in or you plan to be here, we appreciate it because the storm obviously wasn't something good for the turnout, and we have plenty of people. You can hear me? Okay, great. So, before going back to proof of work, because we tend to agree on a lot of the advantages of proof of work, I'm going to play devil's advocate for proof of stake, which is more of a capital investment that you have to make versus all of this mining equipment that a lot of people don't have interest in procuring. So proof of stake is generally best for flexibility. It's very easy to onboard users and to participate in the blockchain protocol. And oftentimes it encourages smart contract functionality, so you can actually do something with the coins other than just hold it, as in Bitcoin's case, right? Proof of stake chains can choose to validate a block quicker with less variances than traditional proof of work chains. The networks tend to be more efficient overall, and that helps for scalability when you get like a lot of people trying to do transactions at the same time, and you actually need those transactions to be settled quicker than, let's say, Visa. Proof of stake is very good for that in general. So if you were to launch a new blockchain, right, you're not going to try to replicate Bitcoin and try to compete with it because it's time tested, everybody knows it, and it's the original, right? It's very hard to topple the original. So if you were to be a new cryptocurrency, a new blockchain protocol, proof of stake, it would be a lot easier just to work on because of the scalability, but it also has downsides as well, which I'll get into as well. It eliminates many overhead variables that may allow interested actors with deeper pockets to have a bigger say over governance and disproportionate staking rewards. So proof of stake is capital intensive, right? So you are promised a return on your investment about, in Cardano's case, about 4% per year. So it's kind of like having a savings account. If you have a savings account and you're promised a return, that means the more capital you put into it, the more coins you're gonna receive in the same amount of time as somebody with, you know, $100. If you had $4 million and you got 4%, that's gonna give you a bigger say over the token allocation of that protocol. And a lot of proof of stake blockchains, they use governance as a tool to give people voting power. But that's typically done based on the amount of coins you have. So if you have more money, therefore you have a bigger say, it becomes, in some ways, like lobbying for your state or local politics. That can happen in many cases. But one thing about proof of stake is that it eliminates the need for all of this hardware as well. Most people don't care about it, using all this stuff. It involves a lot of work. It's very difficult to be competitive in it because mining is a business, and due to that, the same Pareto distribution happens where you have actors at the top with a lot of capital that just invest into the hardware and mine anyway, and therefore they're able to get a larger share of the token supply. In Bitcoin's case, that's exactly what happens. You have centralized farms that do all of the mining pretty much. You can't really do it recreationally at home and be competitive and actually gain the token. So proof of stake allows you just to put your money in and get a return on that. And then basically, going back to proof of work very quickly, it is generally best for giving life to hard money cryptocurrencies. What I mean by that is if you print money out of thin air like what we're experiencing right now in the US, it's very hard to back it up with something other than we said so. At least when you exert energy, just like you would at work, You're providing some sort of value and some sort of contribution in order to get something back. That would be referred to as hard money, right? I'm not printing it out of thin air. I'm actually putting some work in to acquire it. So that's, in Bitcoin's case, that's what makes it the hardest money in the world, actually. But it doesn't have a lot of utility. Like we said, scaling is actually very hard to do in a traditional proof-of-work setting because smart contract functionality is not usually the priority. The priority is decentralization and security. In Bitcoin's case, and a lot of proof-of-work cases, scarcity is baked into it, which creates a deferred reward for early mining business owners if network is maintained secured and decentralized long enough. Due to many complexities of proof-of-work, labor and cheap energy allows for more diversification of actors and encourages a wider pool of miners to participate based on geographic advantages and unique accessibility, meaning if you had access to cheap electricity somewhere out of your, let's say New York, for example, or Massachusetts, where energy prices are really high for various reasons, right? If you were able to go to Kazakhstan and set up the same exact mining farm, well, your energy costs and your overhead is going to be lower, so you're able to profit more off of the mining than somebody in upstate New York. So it allows you to monetize the energy, which is what you were saying before, without the need for cables and things of that nature. And proof of work is more time tested. It generally has less attack vectors and more research behind it than proof of stake. And then on top of that, it's easier just to bootstrap people overall in proof of work because as long as you're able to mine, which in Bitcoin's case is very difficult, but other proof of work cryptocurrency, if you're able to mine, you don't need anybody's permission to start gaining the coin. In proof of stake, somebody, some organization or some team has to kind of create the basis and distribute it out, kind of like an IPO or an ICO where you would have an initial offering of that stock. You know, I'll start at 20 cents and let everybody take on the economics from then on. It's very hard to be decentralized in a proof of work setting. Yeah, I think Cardano does the best job of that, but it still has its shortfalls because there's always this reliance on a central entity to make the rules, to improve it. You get all the software nerds to improve the blockchain, and it can be hard to give that power back to the people actually using it. Proof of work allows you to bootstrap just very easily. You get the coin, you don't need permission, and you can't be deemed a security if you do it properly. And that's kind of it. And one thing that's really important, as we are all living through a time of like deep inflation and we don't really get a vote or say in that, how the monetary policy is conducted in this country, right? One thing that's really important when creating digital assets is like, okay, why do we care about making them in the first place? We already have fiat money, US dollars. I can conduct all my transactions with that. Well, one of the reasons is so you can actually have a say in how things are done. And in order to decentralize a cryptocurrency, that's a very broad term. So for me, the definition is the accessibility to infrastructure or participation in the chain, the degree of encouragement for the widespread distribution of a chain's tokenized assets and initial distribution, how governance is achieved and performed among participants in regards to the direction of that chain's future, and the overall protocol designed to encourage more power away from the core team or initial key players that created the chain and exponentially give away that power over time. So there's no, the short and simple of it, there isn't one better or worse consensus layer design, whether proof of work or proof of stake. It's more of what are the use cases you're seeking to do with that. Are you trying to create hard money that's really hard to reproduce? Are you trying to print something out of thin air and try to give it value and utility by having user adopt it over time and create smart contracts and create NFTs and all these fun things that we've heard about? Are you trying to create a long-term storage of value, which is also really hard to do? So proof of work, in conclusion, it's like decentralization and security are easier to do on that. Because again, it's just, there's no middleman, there's no initial team necessarily trying to distribute these tokens out for a certain price. And then with proof of stake, it's just scalability. It's just easier to get things done quicker if you don't have to worry so much about these other decentralized game theory mechanics, like energy costs and all this stuff. So that's pretty much it from me. Those were all my notes.
All right. Sure. Yeah.
Yes.
Proof of stake. Proof of stake.
Sure. So you have to, when you're mining, you basically have a competition between yourself and your operation of mining and other miners. So it creates what's called network difficulty. So it grows. As more people want the same thing, there's a fixed amount of coins that can be emitted at a time. So basically you're competing to get the same thing, and it's fixed. There's energy involved in that. And if the price of that coin falls too much, pretty much the energy and all the work involved becomes, makes that coin unprofitable to mine in many cases. So in a bear market, it's just hard to mine something worth of value. Yeah.
I should have repeated the question because we have the live stream. But
Yeah, anyone who has a question, let me know so I can give you a mic. So you
The
can catch
question
it on
was,
the
in
screen.
a bear market, which is better, proof of work or proof of stake for someone who's staking or mining? And yeah, staking, because mining, they actually have actual costs that they need to incur. So.
In other words, like it's like if you wanted to manufacture a car and you had to compete with that, and somehow the economy goes to hell, like may happen right now, and we go into recession. Well, it may not be too profitable. There's not enough people buy the car. Proof of stake eliminates all that, so you can still have those coins without all the hardware and the energy, but it still may be volatile, like as a storage of value. So in a bear market or even in a bull market, you don't really know when they'll start or end with cryptocurrencies, and they're just a bad storage of value over time, at least this far in, if you're looking at a short term, But if you look at long term, Bitcoin has always held this price over time. It's always proven to come right back up and go up further up until now. So it's like a long term thing, But the utility's there. So it's basically open source software for Bitcoin, and a lot of this is just software. It's just a bunch of nerds coding and making something out of nothing, and actually giving it value through the security and the distribution of the coins and what you can do with it, like NFTs, for example.
So real quick, can you address the concerns around, like for example, like the government taking over, let's say Ethereum, because it switched to proof of stake, and a lot of the network is here, run in the U.S. versus anywhere else?
Yeah, well, I think Ethereum would be a good example of something that would become a security myself. So I'm not like, we need regulatory framework for some things. I think Ethereum is very top-down, and if you look at the parameters I gave for what would constitute decentralization, in my opinion, people have no say in what happens with that protocol. They went proof of work to proof of stake, so they transition without letting any miners really have a say in it, right? And yeah, they just do things unilaterally. I would consider them a security.
Yeah, I think an important thing to consider with Ethereum and proof of stake is that part of it is the way that Ethereum implemented proof of stake, that you need to have 32 ETH, which I guess is about $50,000 today, in order to stake in a decentralized way. If you don't have that 32 ETH, then you need to give it to someone else, and then it's basically giving your money to a bank. And not every proof of stake protocol is implemented in that way. Some proof of stake protocols, like you mentioned Cardano, inside the protocol you can delegate that stake to someone, so there is less trust involved.
Being deemed a security is kind of like a dirty word, people don't like it. But in Ethereum's case, I think it's great if they were more institutionally adopted. And since they have all of this deflationary stuff with their transaction fees, it becomes something more approachable to institutions. If it were me, I would just let Ethereum be that for institutional bankers and things like that, and just kind of have them be the Netscape of the 90s, and kind of let other blockchains that do a better job at proof of stake and proof of work prior take over, like Cardano or Nervos or Ergo. Yeah, they were just first to do things properly, so.
Probably a question that maybe it's not possible. Are there any hybrid coins that are half proof of stake, half proof of work?
That's a tough
Yes.
one. Yeah, there is.
What was it? Name one. Yeah. I can't remember what it was.
That's a good question. There are kind of
The tip of my tongue, I can't remember.
There are coins that take like, they coin their own, no pun intended, but they coin their own consensus layer, like proof of authority.
Sure, that's just like a reputation system.
Yeah, yeah. So, but as a hybrid, you kind of need one approach for a consensus layer. How are we going to get everybody on the same page for the blockchain distributed ledger, right?
There is one, if I remember.
What? Oh, what about Avalanche? Like, what does that consider?
Proof of stake.
That's
Proof of
more
stake.
proof of stake still because okay.
Yeah, there's.
so-
Yeah, go ahead.
Well, they have the whole like snowflake, snowball, avalanche thing, which is really just a protocol for communicating between nodes, but actually like what makes the what is used to determine the consensus, that's all proof of stake.
Right. I have one more question. There's like some companies now that are doing where, okay, you get this NFT that's not actually like an actual NFT, but more so a, what's the word I'm looking for? Like it's like a identification for yourself. And basically, instead of taking data from you where it's personalized, they kind of just automatically sell like more like basic data, like, you know, maybe your age or something like that that's not personalized to you. What would that be considered? Like, is that still considered mining technically because you're making your own money off of the data automatically being sold?
No. So
Okay.
all that's happening like in like a smart contract. So if you wanted to run that like in a distributed system, you need like proof of work or proof of stake underneath it, and then that is like a smart contract running on top of that system.
Right. But that's more so proof of stake because you're not really doing any work. Like you're necessarily just, like you have this NFT that they're using to identify you and your information is just being sold where they profit, but you're also getting your own profit from whatever information they get from you.
But it's occurring at like a higher layer.
Okay.
So like the proof of work, proof of stake thing is like down here, and then like similar to like your computer, like you have like your operating system, and then you have like applications that run on top of the operating system. So like the proof of work, proof of stake conversation is like down here in the operating system, and then they're just like an application that rides on top of it. Decred is the hybrid. Decred, D-E-C-R-E-D, they're hybrid proof of work, proof of stake. Dash.
So real quick, I know Anthony said a word called consensus mechanisms. So just to clarify, a consensus mechanism basically is something that people agree on to secure a network. So basically at its core, whether it's proof of stake, proof of authority, proof of work, it's just people agreeing to secure a network in some way, shape, or fashion, and then they get incentivized for it. Question?
More questions? Let's go. Great.
Hey, so I remember, Anthony, you were talking about how mining pools pose a centralization risk, but the way it sounds, how proof of stake is, sounds like there's more of a centralization risk in that, because unless I misunderstand, it's
You're
the
right.
more staking
yeah.
that you have is the more transactions you get to validate. Is that correct?
You have a greater likelihood of artificially minting a block, yeah. So it's just, you need money for both things. It's always gonna, most of the things are gonna end up at the top either way. It's just, how do we choose to onboard people? So if you had a lot of money, you could put that into a big mining farm. If you had a lot of money, you could just buy a bunch of ADA and maybe even mint your own blocks if you had your own staking pool. You could pledge it all yourself. So the barrier, you know, there's 51% of tax, which you mentioned. You know, if you had enough agreements across certain mining pools, you could technically attack the network and kind of go back a few blocks. You can do all terrible types of things in both situations, and that's usually down to, I would say, you know, how do you distribute those tokens to make sure that it doesn't all just rise to the top? A lot of these cryptocurrencies, in my opinion, they look more like companies. And they have all of these different token allocations like insider seed investors, team allocations, all of these different types of things. And some of them do it responsibly and some of them do it just to enrich themselves. And it's pretty evident which ones those are sometimes. there are some that do it responsibly. I think Nervos does a great job responsibly. Cardano does a great job. Ergo, which nobody knows about, but Ergo is a great one that almost all of it is fair mined. There's no investors, there's no nothing. It's like an emulation of a Bitcoin 2.0 with smart contracts. So it's trying to take the best of what proof of stake usually offers, which is the smart contracts to create like dApps, like what you were saying about the identity thing. And then also just make sure it's still fairly mined, and also ASIC resistant, where you don't need, no offense, but you don't need, you know, expensive ASICs to mine. The barrier to entry is the GPU, so it's basically what you would find in a gaming computer. Everybody can participate and get involved, although it comes with its own challenges as well. Yeah. Yeah, sure. Oh.
For the stream.
Okay, so the Earth needs more free energy. And so if you have proof of work, such as Bitcoin, like they're going to use a volcano in El Salvador, then you're going to have much more of innovation of how to get energy for free. Yeah. So I would think that proof of work would be better for the planet.
In the cases that you have a novel use case for some natural, you know, like in El Salvador is geothermal, you know. If you have that and it's just burning, you might as well use it for Bitcoin. But the problem, I suppose, on the other side of things is like, for example, when Bitcoin mining was really predominant in China, most of it was coal. They were just burning coal. They don't care, a lot of the miners. So, yeah.
Power. Mostly they used water power. Power.
Yeah.
The thing I really
Hydro.
like, hydro.
Hydro, yeah.
The thing I really like about Bitcoin mining is that it just sounds so stupid to someone like looking up to it, of like, oh, you plug in these things that turn electricity into heat and generate internet money. Like someone would look at that, you know, just without really looking into it and say that's a terrible idea. You're just wasting energy. But it does drive these conversations around, around coal, for example, of why is coal available? I mean, I know there are power plants that have been powered up specifically to mine Bitcoin, and that, you know, probably requires enforcement of just local regulations that should already be in effect, that they shouldn't be, you know, allowed to reboot coal power plants. But that idea that we're using fossil fuels for anything in 2022 just seems ridiculous. And I like the idea that Bitcoin mining like presents that to the world and says, you know, why do we allow this to happen? You know, we don't live in a world where Bitcoin mining exists outside of local regulations. If it's illegal to, you know, use a coal-fired power plant, then like it would be, regardless if there's Bitcoin or there's not. But I think the issue is more that there are fossil fuel sources available, rather than, you know, Bitcoin miners can use them.
The energy narrative around Bitcoin is very complex, right? Just renewables in general, we can't shut off fossil fuels overnight, like, you know, with Europe. They're so dependent on Russian oil for all this time. Now they're in a trouble because they don't want to do it themselves, so they get it from somebody else. In Massachusetts, energy bills are really high because they're not allowed to, you know, do the fossil fuel energy extraction there. They have to transport it from Canada, which doubles the cost of the actual electric bill. It has delivery fee and then actual electric fees. So it's hard to like wean off of fossil fuels overnight, but ultimately we should. It just has to be gradual. And then Bitcoin, the good thing about it in terms of what it incentivizes you to find a lower and cheaper source of energy that would be usually below fossil fuels, like solar panels and stuff, or wind and things like that. So it helps to kind of shut off those dirty forms of energy and find a cheaper, more sustainable one, because it's better for your mining business, which is cool. And it makes up such a low percentage of what the world uses in electricity. You know, all the dryers in the US use more than Bitcoin. It's not like Bitcoin is just using as much proportionally to anything else. Like Christmas lights in the winter here in the US use more, or approximately the same amount as Bitcoin mining. At least you're getting a hard decentralized asset that is ungovernable by a country. And that's good. I mean, You don't want your money to be manipulated too much. Everybody else suffers when it's done irresponsibly. It's centralized. It's not good to do that. But nevertheless, there will always be pros and cons to proof of stake and proof of work, because, like, again, not everybody wants to mine. Maybe you just want to throw in $100 and buy something and get something back from it. And know that it's capped. If it's capped, it's great, because you know nobody can make more of it long term. So it's kind of like an early investment into technology, a different form of it.
Any last minute questions, comments, concerns?
A lot of it can be confusing. I recommend, if you guys are interested, any questions you may have after, just type them into Google. I promise you 100 other people have tried to ask the same exact thing. And it's a lot of information too, so I appreciate you guys sticking around trying to indulge it. And I appreciate you for inviting me to speak, so yeah.
It's great, yeah, thanks everyone.